Lesson 47A, we're going to start factoring some polynomials. Okay, what is factoring anyway? Factoring is when you break something up into multipliers, like like a 12. If you broke up a 12 and you said, hey, that's 2 times 6, well, guess what? You just factored the 12. These are called factors of 12. 2 is a factor of 12. 6 is a factor of 12. So 2 times 6 is a factorization of 12, and you get the idea. Of course, 12 can be broken up different ways. You could say 3 times 4 if you really want. I suppose you could say things like -3 times -4. Anyway, that's what factorization means. Break it apart into like multipliers. So that's what we want to do with this one. So when you look at that thing, you'll say, well, how am I supposed to, I'm supposed to multiply two things together and get this, x squared minus 4. This is, it turns out, a pattern that you just need to recognize. The pattern is called a difference of two perfect squares. You look at the x squared and you say, oh yeah, that's a square, right? Somebody squared x, so that's a square. How do you get a 4? Well, you could square a 2 to get 4. 2 times itself is 4. So what you do is you say, oh, that's the square of x. And that's the square of 2. So you see this x and this 2 here? Those are what you need to write your answer down. You need to go like this. And like I say, this is just a pattern that you need to know about. It goes like this. You take that x, you take that 2, and you go x minus 2, and then you go x plus 2. And it works. Here, I'll prove it to you. What I was saying is that you should be able to multiply those two things, multiply this times this, to get x squared minus 4. Well, let's FOIL it, make sure it works. X times x would be x squared, right? Yep. X times 2 would be giving me a 2x. Okay. Now minus 2 times x gives me a minus 2x. And then minus 2 times 2 gives me a minus 4. But notice that the plus 2x and the minus 2x cancel, and you're left with the x squared minus 4. Works like a charm. Works like a charm. So like I say, it's just a pattern that you just got to know. It's like received wisdom. It works. It works. I guess we could write this as a formula. Formulas are basically meant to help you remember a pattern. So you want to be as general as you can. So instead of using a specific example, we'll say a squared minus b squared, where a can be like practically anything, b can be like practically anything. But the idea is you got something here that's squared, and you have something here that's squared. How do you factor that? Well, you take your two somethings that are squared, your a, your b, you take those two things, and you subtract them, and then you add them. So that is the formula for factoring a difference of two squares. Okay, so again, I was starting to say the formula is there to remind you of the pattern. So you look at this and you say, okay, I got something squared minus something squared. Take the something and minus it. Take the two somethings and add. Okay, that's what I do. So I'm gonna not use the formula directly when I'm doing the rest of these. I'm just going to use the pattern. Okay, so the formula again reminds me of the dance steps I have to follow. So what do we got down here? This minus this. Could this be a difference of squares? Well, it's certainly a difference, right? Minus is certainly a difference. Are those squares? Well, I do see some exponents of 2 flying around, but you have to look at the whole term and say, what would I multiply by itself to get this whole term, 49x squared? And the answer is I could multiply 7x times itself to get 49x squared. So that's good. That's a perfect square. Now look at this entire term. What times itself gives me 25y squared? And it's 5y times itself. 5y times 5y would be 25y squared. So notice I do have a difference of two perfect squares. So how do I factor this? You minus them, you plus them. You're done. Unless you want to FOIL it out just to check yourself. You could FOIL it out just to make sure it's working, but trust me, it works. Ooh, look at this thing. Whoa. Okay, well, is it two perfect squares? That's the question. So I'm looking at the 1 first, because that's the easier one to look at. What times itself is 1? Well, 1 times itself is 1. Okay, so that's going to work. Now what about this. Can I square something? Can I multiply something by itself, in other words, and get this? What times itself gives me 4x to the 6? Well, 2 times 2 gives me the 4, and x cubed times x cubed would give me x to the 6th, right? I mean, if you saw this as a homework problem, you'd multiply the 2 times 2 is 4, and remember, you would add your exponents to get x to the 6th. So yeah, that's working. So these are both perfect squares. So the square root of 4x to the 6th, if you will, is 2x cubed, and the square root of 1 is 1. And since it's a difference, it has to be a difference. Since it's a difference of two squares, I can simply say, okay, take those and subtract them, take those and add them. And it doesn't, by the way, particularly matter if you put the plus first and or the minus first. That doesn't matter, as long as you've got a minus and you've got a plus. Cool, so that's how the difference of squares works. So again, I've got a formula there that you can use just to remember the pattern. Now, differences of cubes, there's also a formula for this one, and it's a bit of a fancier formula. I think what I'll try to do is I'll try to do it by dance steps first, then I'll give you the formula, and then I'll just keep using the formula. But I do want to try to get you to learn these dance steps first. First of all, you do kind of the same question. You say, okay, is this a difference of cubes? Like, x is a cube, right? X is being cubed here. So yeah, I've got an x being cubed. That's what that is. Now, is there something times itself that equals 8? And the answer is yeah, there's a 2 times itself is 8. So these are both cube rootable. So you get an x cubed and you get a 2 cubed. Now what I got to do, actually let me move this a little bit and let me get rid of some of this mess here. Okay, what we got to do is we're going to dance with the x and the 2. So remember how we danced up here. Up here I had an x and a 2, and I just said, oh, x minus 2, x plus 2. That's all I had to do. Well, here I can start the same way. I can say x minus 2, and here's where the dance is different. So now I take x times itself, I say plus. I take the 2 times the x, I say plus. I take the 2 times itself, I say 4. Instant replay. I took the x and the 2 and I put them down here and I subtracted them. Okay, that was as though it was a difference of squares. That's how you would start doing a difference of squares. But then in the next parentheses, you have to do something different. You take the x by itself, you take the 2 times the x together, you take the 2 by itself, like this, and this is all added together. That's the dance. So I encourage you to, try that dance, so to speak. Try to get used to it. Little repetition, of course, is how you would get good at that. Meanwhile, at first, you may wish to use the formula. So I'll give you the formula. The formula goes like this: a cubed minus b cubed. Okay, so if you've got something that's being cubed minus something else that's being cubed, we'll just use a and b to stand for whatever the somethings are. The formula is, first, you take the a minus the b, just like we did up here. But what's different is what happens over here. You have an a squared plus a times the b plus b squared. That's the formula. So like I say, the main use of the formula is to remind you of the dance steps. I encourage you to try to get used to the dance steps. But you can also use this formula directly, which, hey, you, what are you doing? Come back out. What? Come on. Sheesh. Okay, so anyway, yeah, let's use this formula now. So first of all, let's look at this next problem here and say, do I even have a difference of cubes? I guess you want to know that first, right? This only works for a difference of 2 cubes. Now, the x is being cubed, so that part, I guess, makes sense. What's the cube root of 125? Does that come out even? Is there a number that times itself, you get 125, and you just kind of try things. You say, well, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 works. Okay, so it turns out 125 is one of those perfect cubes. You'll learn to just recognize that after a while. Oh, 125, my old friend. Yeah, that's 5 cubed. So anywho, This is a difference of 2 cubes. Now let me kind of move this up again so I have more room. That means I'm going to use this formula. Hey, I wonder if I could just copy this. That'd be cool. Copy. Yep. Now how do I paste? Paste image. Oh, look at that. Perfect. That's the first time I ever tried that. So anyway, there's my formula right there. Move you up a little bit. Move me up a little bit. In fact, I'll go like this, really. So that way you can see that I'm going to use A is X, and that means that where I see an A, I put an X, and where I see an A, I put an X, and where I see an A, I put an X. And then, maybe I'll get a different color. Where I see a B, it's a 5. So where I see a B, I put a 5. Where I see a B, I put a 5. Where I see a B, I put a 5 squared. And I really should be good about all this. It's actually x minus 5. It's an x squared plus a 5x plus a 5 squared. So if you just kind of write this out nicer, x minus 5, x squared plus 5x plus 25. And that works. When you multiply those two things together, it's a lot of multiplying. But when you multiply those two things together, it will simplify to just that. X cubed minus 125. I invite you to try that as an exercise just to prove it to yourself that, wow, when I multiply all this stuff together, I really do end up with just that. That's amazing. That's cool. I can dig it. Okay. So what am I going to do now? I'm going to move this stuff out of the... Maybe I'll shrink it down a little. Hey, I said shrink. I'm going to shrink it down a little bit. Oh, I wasn't able to shrink the formula. I'll just delete it. I'll just undo everything. I just did. Never mind. Okay, so let's just try to squeeze this one in over here. Here's another one. 27x cubed minus 1. Okay, so the questions has to be, first of all, do I really have a difference of 2 cubes? Well, 1 is something I can cube root. If I use b equals 1, then of course b cubed equals 1. So that's okay. Now what about this term? Again, you have to look at the whole term. I got a 27x cubed here. What would be the cube root of that whole term? And it turns out it does have a nice cube root, 3x, right? Because if you take 3x and you cube it, well, that's a 3 cubed times an x cubed, and 3 cubed is 27, and so it really does work. And so we're going to need to use this, we're going to use a is the same as 3x, b is the same as 1 in that formula. And rather than copy the formula, I'll just direct you up like this. So I'm using a 3x minus 1 to get started. Now, put the 3x here. Now you have to square the 3x. A 3x. Squaring the 3x makes it a 9x squared. Be careful about that. Plus, and now I'm supposed to take the a times the b, which means the 3x times the 1, which is 3x. Plus, and now I'm supposed to just put the b over there and square it. Well, that's a 1 squared, which is still a 1. And so there you go. And again, you multiply that stuff out, I guarantee it's going to simplify to just that. It's an amazing thing. Okay, so differences of cubes. If you haven't seen these before, they do take a little getting used to. It's not a quick thing to have the dance steps memorized. It took me a while anyway. So you might want to just keep this formula handy for when you need it, whenever you need it. But make sure you recognize, hey, wait, this might be a difference of 2 cubes. And if it is, I'm going to have to use that formula. Okay. So differences of squares, a little easier. Differences of cubes, is a bigger formula. Turns out you can also do a sum of cubes. Not a sum of squares, but a sum of cubes. And I'll probably just give you the formula first. It's very similar to this formula, actually. Let's use the same formula color. So a cubed plus b cubed, if you have not a difference, but a sum of cubes. I'm going to put the formula over here. A cubed plus b cubed. You factor it this way. A plus b, a squared minus ab plus b squared like this. Now that formula's got to sound pretty similar to what we just had. It is very similar to what we just had. If you take this formula here and you compare it to this formula here, you're going to find that the only differences are some of the signs. Instead of a cubed minus b cubed, it's a cubed plus b cubed. Instead of starting with a minus b, we start with a plus b. Instead of a squared plus ab, we have a squared minus ab. Notice this part stays the same. That's still a plus at the end. So that's really the only difference, is those signs. But still, keep the formula handy. Keep both formulas handy, really, because you want to make sure you use the right pluses and minuses and stuff, right? But I think we only need one example of this one. In fact, this would be a great time for you to just sort of stop the video for a second, see if you can figure out what's my A, what's my B, and then plug them in to this formula over here and see what you get. Ready? Well, my A is going to be 3x, because if you take a 3x times a 3x times a 3x, you get 27x cubed. And my B, remember, I'm not looking for square roots here, I'm looking for cube roots. The square root of 64 is 8, but that doesn't help us. We need it to be a cube root. And the cube root of 64, it turns out, does come out nice. It's just 4. If you multiply 4 times 4 and then times 4 again, you will get 64. So this is what I'm using for A, and this is what I'm using for B. And I'll just kind of put it right over here. Well, I guess I won't. So I've got A plus B. I'll just copy the formula. A squared minus AB plus B squared. So the A is a 3x plus. The B is a 4. The A is a 3x. Now again, when you take a 3x and square it, you get a 9x squared. Be careful about that. Minus. Now A times B is going to be 3x times 4 is 12x. And then the B squared means 4 squared means 16. And so here's our answer for that one. Cool. So all of these that we've just looked at, these are our two-term situations, right? A difference of squares, a difference of cubes, a sum of cubes, okay? If you have two terms, you want to see if they're one of those situations, because if they are, we've got formulas we can use. Now we should next try to remember how these trinomials things work, right? These are a little more work because you have to kind of fuss around like you're solving a Sudoku puzzle or something. You have to kind of fuss around a little bit with these things. Once you get good at it, you can do these pretty quickly, but at first it's a little bit of monkeying around. But how do you factor that? X squared plus 5x plus 4. The first thing you do is you assume that somebody must have FOILed something to get that. Now when you FOIL, of course, you go like this. This times this, this times this, this times this, this times this, right? That's how you FOIL. So how are you going to get an x squared? You're going to get an x squared when you do this part. The x times the x is how you get an x squared. Okay, so that part, oops. So that part is kind of, I said oops. That part is kind of the fun part. Okay. Now where the work comes in is you got to say, okay, now the 4 is going to come from these two spots. And you don't know how to break up the 4. Is the 4, should I go 1 times 4? Should I go 2 times 2? What should I do here? And the answer is you just try them. If you think 2 and 2 might work, then you know, try some pluses or whatever. Then you'll say, well, let's see now here. I tried breaking up the 4 that way. What happens? I get x squared. I get plus 2x. I get another plus 2x, and then I get a plus 4. I like the x squared. I like the plus 4, but that's not giving me 5x. It's not giving me 5x. Well, if it's not giving me 5x, then that doesn't work, right? That's not how it works, so guess again. Now, the good news is you can cross that off your list because you tried it and it didn't work. So now you say, okay, I guess I'll try the 1 and the 4. And let's make sure this works. I've got x squared, of course. Yep. I've got a plus 4x. I've got a plus 1x. And I've got a plus 4. I see the x squared. I see the 4 is working fine. But notice also, I am getting a plus 5x in the middle. So there she blows. So that's the factoring of trinomials. It's a little bit of trial and error sometimes. But, you know, like I say, a little practice, you get pretty good at this stuff. Oh, let's try this next one. Okay, I love it when they start with just x squared, because if they start with just x squared, then I know that my foiling, or my unfoiling, I guess, but the thing that I foiled has to start with x times x. It has to. That's how you get x squared, is you multiply x times x. So that's the good news. As usual, it's this thing that we have to worry about. So the 6, how do you break up a 6? You could go 1 times 6, you could go 2 times 3. So I could try putting the 1 and the 6 here just to see if it works. I should probably change colors like I did last time. If I put the 1 here and the 6 here, okay, what have I got? I've got x squared, I've got plus 6x, I've got plus another 1x, and 1 times 6 is 6. I like the x squared, I like the 6, but this isn't working. That's a 7x. I don't want 7x, I want negative 8x. In fact, I want negative. So that's not going to work at all. So okay, I know the 1 and the 6 aren't going to work. So good, let's try the 2 and the 3 and see if that works. And by the way, sometimes nothing will work. And if nothing works, just give up. If I have to cross this off too, I'm saying, well, nothing worked. It cannot be factored. That happens. So don't worry about that part. So, okay, 2 and a 3, huh? Well, you know. Now remember I was noticing that this was negative, right? So what I'll do is instead of putting pluses in here, I'll put minuses in here. So let's make sure this is working. X times x is x squared minus a 3x, right? Minus 2x. And then I got plus a 6. And then I was actually expecting this to work, and guess what? It's not working because that's a minus 5x and that's a minus 8x. This isn't going to work. Unfactorable. Unfactorable. So sometimes you get an unfactorable result. You might as well get used to that right now. Boy, I sure hope these work. Okay, so let's try these two. Now this one's a little more fancy because it's not just an x squared, it's a 2x squared. So how does that change things? Well, it basically means that instead of having x times x, right, that doesn't give you 2x squared. You're going to have to do 2x times x. That gives you 2x squared. Okay, so that's the big difference. So if you got a number there, make sure you're taking that into account when you set up your parentheses like this. So I got a 2x times an x. Now as for this 3, well, it's going to have to be a 1 times a 3, isn't it? It has to be. Now the thing is, I could put, maybe I should do it this way. It could be 1 times 3, but it could also be 3 times 1, right? Because I could put them in different spots. Would that matter? Well, let's say I put the 3 here and the 1 here. So I've got my 2x squared. Oh, and then we got to think about these signs here. It's a negative 3. All right, let's slow down a little bit. What are all the ways you can break up a negative 3? You can break up a negative 3 as, you can either multiply negative 1 times 3, or you can multiply positive 1 times negative 3, or you can multiply negative 3 times positive 1, or you can do a negative 1. Wait a minute. Yeah, I messed that one up. Okay, or you can do a 3 times a negative 1. There, I'm trying to get all 4 possibilities here. It's either 1 times 3 or 1 times 3 where the 1 is negative or the 3 is negative. It's either 3 times 1 or 3 times 1 where either the 3 is negative or the 1 is negative. There's the 4 ways that you can do this. So I've got basically 4 things to try. I'll just try one at a time and see if they work. So the first thing I'm trying, I guess, is I'm trying this minus 1 and a plus 3. Will that work for me? 2x squared. Yep, that works. Plus 6x minus x minus 3. Well, the plus 6x and the minus x are not giving me what I want here. They're giving me a plus 5x. I want a minus 5x. So that didn't quite work. It almost worked, but it didn't quite work. So that's not going to work. How about if we try this one? Oops. How about if we try this one? So I put a plus 1 and then a minus 3 like this. I think this is going to work because notice we got 2x squared. We got minus 6x. We got plus 1x. And then we got minus 3. And so I got the 2x squared just like I want. I got the minus 3 just like I want. And the minus 6x and the plus 5x really is giving me the negative 5x. There it is. That's our answer. So we have found it. Let's get this stuff out of the way so I can circle it. Okay. So trinomials can be a little bit more work. But like I say, with practice you get faster at them. So one more of these things. What's this thing saying? 6x squared plus 13x minus 15. Now this one's about as tough as they come, and that's because we have different ways to break up the 6x squared. We could break it up as 6x times x. Yep. But we could also break it up as 3x times 2x. Right? There's more than one way to break up the first term, in addition to having more than one way of breaking up the last term. So unfortunately, you don't know which of these it's going to be, so you just have to try both of them. So I'm going to say, okay, what are all the ways I could break up a negative 15? Well, you could use a 1 times a 15, a 3 times a 5, a 5 times a 3, a 15 times a 1, and you could use you could do it where this one's negative, this one's positive. Or you could make the same list again, 1, 15, 3, 5, 5, 3, 15, 1, where the first one is positive and the second one is negative. So if I wanted to list all my possibilities, there's 8 of them. So that's listing them all out. Then you start trying them. Now, after a while, you get pretty good at figuring out which ones you want to try. But at the moment, I'm just going to run blind here because sometimes that's just what you do. So I'm going to put a minus 1 and a plus 15 here. And while I'm at it, I'll try this one. Does either one of these work? Now, really, I could just check the outside and the inside terms. So 6x times 15, well, that's 90. That's way out. That's not going to work at all. So I can cross off that. Okay, so 3x times 15, well, that's like 45. How am I going to get a 13 if one of my numbers is a 45? Okay, this is not going to work. Cross it off. It is not going to work. Let's just try something else then. Something a little less freaky. How about if we try this one? So that didn't work. A negative 3. And a plus 5. Let's try that one. I'll try it here, and I'll try it here. So I'd have a plus 30x and a minus 3x. That's not going to give me 13. How about over here? I got a plus 15x and a minus 6x. Well, that's not going to give me 13 either. Huh. That didn't work. Wow. I hope something works. So the good news is, even though it's taken a while, at least you know that there's only a certain number of things you can try here. How about if I try that next? A negative 5 and a plus 3, a negative 5 and a plus 3. So now I've got a plus 18x when I do that product, and a minus 5x. And boy, did we just get lucky, because those will give us the plus 13x. The 6x times the x, of course, will give me the 6x squared. The minus 5 times 3, of course, will give me the minus 15. And I just showed that I'm going to get the plus 13x in the middle. So I know that that's my answer. So I can just go like that. So there's a little bit of value in being methodical about this. Just list out all your possibilities and then carefully try each one. Cross them off. If you get to the bottom of the list, this list wasn't big, but we got to the bottom of this list and nothing worked, you'd say it's unfactorable. So you know that, you're at least there's a limited amount of work to do. It's not going to go on forever. Some people worry about, it's going to take forever. Well, it might not, or it can't really, because there's only so many guesses you can try. Anyway, so when the 6x squared can break up 2 ways, well, it makes your task twice as big, I guess. but the rest is the same. Take that negative 15, list all the ways that you could possibly break up negative 15, and then try them. Try them one at a time until something works. And if nothing ever works, it can't be factored. Now, another thing to keep in mind. We've done differences of squares, differences of cubes, sums of cubes, and trinomials. Okay. There's another kind of factoring that is very important, partly because you should always try to do it first. Sometimes you'll get something like this, and you'll say, is that a sum of squares, a difference of... I don't know what... That's not. It's not a sum of squares, not a difference of squares. But can I do anything at all? Yeah, I can do something. I can, what's called, pull out a common factor. That goes like this. You sniff at this, and you sniff at this, and you say, what have they got in common? Well, notice 4 and 12 both have 4s in them, which means I'm going to be able to sort of pull a 4 out. Actually, x squared and x. So both of these terms have x's in them. They both have 4s. They both have x's. So what do? I pull out a 4x like this. Now you open up a parentheses, and you put your leftovers in there. So I'm going to get this out of the way. So if you were to have kind of divided off or canceled off a 4x, you'd be left with an x here. And if you had canceled off a 4x here, you'd be left with a 3. Okay, so this is what I mean by when I say put leftovers inside the parentheses. What we have basically done is backwards distributing, so to speak. Because if you take this and distribute, you will get 4x squared. And if you take 4x times 3, you'll get 12x. And that's what we had, right? So if we took what we wrote as our answer here, if we distribute this, if we distribute the 4x into the x plus 3 like that, we get back our answer. So to factor this is to go in the opposite direction. It's kind of like to take back the distributing, undistribute. What did you distribute to get this? Pardon me. Sort of like up here with these trinomials, right? The question was, what did we FOIL to get this? Well, here it's, what did we distribute to get this? Okay, so it's kind of thinking backwards, unmultiplying. Unmultiplying. So unmultiplying is kind of what I mean when I say this, pulling out common factors. Greatest common factors is another phrase you'll see on the internet or whatever. So let's look at this one. So you see these two terms. Now, before you go saying, hey, that's not a difference of squares, first you should try to sniff out common factors. Notice 3 and 75. Those can both be divided by 3. They both contain a factor of 3, is another way of saying it. Both of these terms contain an x. I mean, this one's got x cubed, but this one's only got x. So I can only get x from both of them. So put the x out front and pull it out, and then say, oh, what have I got left? If I were to sort of divide the 3x out, I'd still have an x squared. And if I were to divide the 3x out of here, what would I have? I'd still have a 25. So let's just double check that this is working. So the 3x times the x squared would give me a 3x cubed. The 3x times the negative 25 would give me a negative 75x. It worked! And now I get to bring up the second point here, which is factoring completely. Once you've factored, you should take a look at your result and say, can I factor some more? Like 3x, well, that you can't do anything with that, but this, can I do that some more? Recognize I've got two terms, a difference of two terms, and they are squares. That's an x squared, 25 is a 5 squared. So actually, I should do this one step further. X minus 5, x plus 5. Remember, that was the pattern for a difference of two squares. So always factor completely. Once you've factored, take a look at what you got and say, can I do anything else? On that theme. Let's see, we got 2 more to go? Oh, we got 4 more to go. Okay. So on that theme, you look at these two terms and you say, what have I got here? Well, I got 3's. Yeah, that's about all. 3 does go into 48, but that's about all. So I'm going to pull out my 3. leaving me with x to the 4th minus, and 48 divided by 3 is 16. Okay, well, that's pulling out the 3. Let's move that up a bit. Okay, now, what about this x to the 4th minus 16? Can I factor that any further? And the answer is actually, yeah, they're both squares. Those are both square rootable, you might say. They're both perfect squares. So you've got 3, because what times itself is x to the 4th? X squared times itself is x to the 4th. What times itself is 16? That's a 4. So you can do that as an x squared minus 4 and an x squared plus 4. Pretty cool, right? So you kind of keep factoring. And by the way, you catching this? That's a difference of squares. We're going to go again. Take the x squared minus 4. That's an x minus 2 times an x plus 2. Now the x squared plus 4, you cannot factor that any further. Right? Because if you did x minus 2 times x plus 2, you'd get this. You'd get x squared minus 4. Some people say, well, what if I do x plus 2 times x plus 2? Well, you'll get x squared. You'll get plus 2x. You'll get another plus 2x plus 4. So you get x squared plus 4x plus 4, which is not what that is. So trust me for today. Sums of squares, nope, don't do them. Difference of squares, do them all day long, but sums of squares, nope. All right, let's see, what do we got here? This one, okay, here we got 2 terms again, and you want to sniff what they got in common. Does 56 have a 7 in it? The answer is yes. Notice both terms have an x. Okay, so I'm going to pull out a 7 and an x, and as a tip, see that negative? It always makes me a little squeamish to have a negative in the front, but that's okay. What we can do is we can pull out a negative 7x. Let's make that negative go a little higher. A negative 7x. So if I pull out a negative 7x from both terms, what does that leave me? Well, if I pull out negative 7x here, if I think of like dividing, I'll be left with an x cubed. If I were to divide by negative 7x here, I'll be left with a minus 8. So negative 7x can be pulled out to the front, leaving an x cubed minus 8. Now in the name of factoring completely, we need to take a close look at this and say, is that a difference of squares? And you say no. But then you say, is it a difference of 2 cubes? And you'd say yes. In fact, didn't we do this one? I think we might have actually done that one. X cubed minus 8. Let me take a quick look up here. Did we do that? X cubed minus 8? We did right here, see? We did x cubed minus 8. So you can review right there to figure out how we got that answer. So this ends up being the x cubed minus 8 factors as x minus 2, x squared plus 2x plus 4. And that would be called factoring completely. By the way, this won't factor any further. When it comes from the cubes formula, just trust me, that part's not going to factor any further. So you might say, hey, it's a trinomial, I should try. And it's like, yeah, you can try, but it's not going to work. Okay, so now we've got 2 more. Okay, so what do we got here? Well, it's a trinomial. Now, before we start trying to break up the 8x squared, this will save you some grief, actually. Take a quick look at all these terms and say, can I pull something out? Like, for example, that 8. Can I pull 8 out of a 40? Yes. Can I pull 8 out of a 48? Yes. Let's do that. So you pull the 8 out to the front, leaving you x squared minus 5x minus 6. And all of a sudden, you've got a trinomial that looks a lot nicer than that one. We do have to try to factor this some more, because it may work. But I'd rather play with that one than the original. So leave the 8 there. That's part of your answer. But this x squared, well, that could break up as x times x. And then you monkey around with the negative 6. And before too long, that's not going to work. Never mind. What's going to work here? I think it's going to work to use a negative 6 and a plus 1. Let's just see. Let's just make sure that works. So I'd have an x squared plus a 1x minus a 6x minus a 6. I like the x squared. I like the minus 6. Notice this gives me the minus 5x that I wanted. So yep, that did work, which means that would be factoring completely. And the one more. Now this one, the first thing I notice is it's kind of out of order. You see how the x to the 5th is way over here? Usually you want your highest powers first. So you don't have to do it this way, but I certainly prefer doing it this way. I'm going to put it in order from highest to first. Highest exponent to lowest. So minus 4x to the 5th will go first. Then I'll put the negative 11x cubed. And then I'll put the 3x at the end. There we go. That to me is more comfortable to look at. Even though I got a negative here, which does make me squirmish, I still like having the big exponents first. All right. Now, before we even think about trying to, unfoil this thing, we should first try to say, well, is there anything in common to all of these terms? Try to pull something out in common. And right away, you'll notice that all of these terms contain x. We're going to be able to pull out an x. Now, I'm going to use the same trick I did up here. It's not really a trick, but the same thing I used up here, which is say, okay, I don't like negatives in front, so as long as I'm pulling out an x, let's pull out negative x. So, if I were to divide negative x here, what would I end up with? I would end up with positive 4x to the 4th. I guess I don't have to write the positive. I would end up with positive 4x to the 4th. Okay. If I were to divide by a negative x here, I would have a positive 11x squared like this. And if I were to divide this by negative x, I would have a minus 3. So first I pulled out the negative x. Okay. This is a trinomial. We want to try to unfoil that. Now I think I'm just going to make a little note to myself that says, oops. I need a note that says, oops. I'm going to write a note to myself that says, save that for later. I want to work on this right now. So it's 3 terms. I should try to do this unfoil stuff. How do you break up 4x to the 4th? There's 2 ways. You could break it up as 4x squared times x squared. You could break it up as 2x squared times 2x squared. Okay, so the x squared times the x squared gives you the x to the 4th, but the main issue is it 4 times 1 or is it 2 times 2? So I'm just going to have to play with both of these. Now the 3, okay, shouldn't be too hard to play with the 3 here. Now if I list all my possibilities, I've got a negative 3, so what's all the ways I could break up negative 3? I could either go 1 times 3 or 3 times 1. I can either go 1 times 3 or 3 times 1. Why'd I say it twice? Because I don't know if the first one's negative or if the second one's negative. That's why. So I got 4 things to try. That's not so bad. 4 things to try. So I guess the first one I'm trying is this one. Let's see if it works. Minus 1 and a plus 3. So when I FOIL, I will get 4x to the 4th. I kind of knew that. I will get plus 12x squared. Then I will get minus 1x squared. And then I will get minus 3. I kind of knew that. And lo and behold, look how lucky I am today, because these really do combine to give me the 11x squared that I need. So that was lucky. I got it right away. So let me switch back to blue. So this worked. This worked. 4x squared minus 1 multiplying an x squared plus a 3. Okay, so in the name of factoring completely, you need to look at these 2 things. Can I factor this any further? Can I factor this any further? Well, that's like a sum of, and it's not a cube. 3 is not a cube. You can't take the cube root of 3 evenly. So that's not going to work. But this one, that is called a difference of 2 squares, right? You can take the square root of 4x squared to get a 2x. You can take the square root of 1 to get a 1. So you split that first term up as 2x minus 1 times 2x plus 1. And then don't forget your x squared plus 3. And while you're at it, don't forget this part that I was saying we should save. We should save that there's a negative x out front. there is the full factorization of what was an innocent-looking trinomial. It actually, if you factor it out, it looks like this. Now, if you want a real nice exercise, try multiplying all these things together and make sure you get back what we started with up here. It'll work. It'll work. Okay, so there's our nice big introduction to, or not introduction, review of the major factoring methods for polynomials. 47b, by the way, is going to be factoring by grouping. I decided I would split that off separately because it's kind of its own thing to try to get. But okay, cool.